All right, my dears, binomial distribution. Here we go. When you have a repetition of independent trials in which there are just two possible results, either success or failure, then this is called a binomial experiment because there's only two possibilities, right? Let probability of success be P, and the probability of failure be Q. So to find Q, it's just 1 minus P. Yay? Okay? And X is the random number. Let X be the total number of successes in trials. Right? Yeah. Okay. Here we go. Once upon a time. You have a spinner. It has 3 blue edges and 1 red edge. When on each occasion that it's spun, you'll either get a red or a blue. So if P is the probability of getting blue, that's success, right? Then Q would be probability of getting red. So the probability of P is 3 over 4. Q is 1 over 4. Yay? Okay. Consider twirling the spinner N 3 times. Now let the random variable X be the number of blue results which occur. So that means your X is either no blue, 1 blue, 2 blue, or 3 blue. Yay? Okay. So the probability that all of them are red. So you spin it 1 time. That'll be 1/4 times 1/4 times 1/4. And are there any other combinations that can happen? No. So would you agree that there's only one way to do this? Yeah? So this thing is just 1 times 1/4 to the 3rd power. Yay? Okay? Probability you get 1 blue. So you're going to have a 3/4, and then the other 2 are going to be red. So 1/4 and 1/4. Right? How many different combinations can we get with that? 3. Just imagine that 3/4 would be the first one, the second one, or the third one. So would you agree that there are 3 ways to do this? Yay? All right. So this would be 3 times 3/4 to the 1st power and 1/4 to the 2nd power. Let me change this real quick. Anybody want Chick-fil-A? We're good. Oh, what shirts?
Do you have an Amari sentence?
I do not. Sorry. Yep. All right. Real quick up here, this could also be written as 1 3/4 to the 0 and then 1/4 to the 3rd. Do you agree? Yeah, because nothing happened. Yeah? Okay. See where I'm going with this? Yeah? All right. Here we go. So 2 blues and 1 red. So you can have a 3/4, a 3/4, and a 1/4. And how many different ways can that happen? 3 different ways, right? So would you agree that that's 3 times 3/4 to the 2nd, 1/4 to the 1st? Yay? Okay. And then, here we go. The possibility of having 3 blues is 3/4 times 3/4 times 3/4. There's only one way that can happen. So would you agree this is 1 times 3/4 to the 3rd and 1/4 to the nothing? Yeah? 1 3 3 1. 1 3 3 1. Pascal. It's Pascal's triangle. Oh. Right. Yeah, binomial distribution is Pascal's triangle, 1 3 3 1. Notice the exponents always add up to 3 in the 2 possibilities. And that's it.
Wait.
So, yellow. To get to the next one. So, like 1 plus 2 is 3, and so on, right? And if you don't know how to get those numbers, it's from combination. So, if you take a look at this, this is the suggestion. So, it's 3 choose whatever. 3 choose 1, 3 choose 2, 3 choose 3, 3/4, 1/4, and then the probability that goes into it. Right? Binomial is so easy. It's so easy. I even like the notation. Here we go. So, in the case where this, okay, yeah. Let's change it to what we're using. Here we go. In the case that there are X successes, right? So that X equals X. Sorry about that. I don't know why I changed the variable from X to R. Right? So P is just going to be the combination of n choose x. Do you know that notation? Right? N choose x. Very good. P to the x, and then q to the x minus 1. Right? And again, I don't know why. I just changed the r's to x's. Anywhere you have a baby r, just change that to an x. Yeah? So the notation for binomial notation is binomial distribution is b to np. Usually we see this like x is a random probability distribution such that it's a binomial distribution with n probabilities, p being the probability of success. Yay? So you can have the number of times it happens and total times and then the probability of success. Yeah? And so remember that n choose x is also written like this. Yeah? It's not bad. It's not bad. Here we go. So, given that x is a binomial distribution with n being 8 and the probability of success being 1/4, the probability that x is equal to 6, right? So you would just go 8 choose, right? And then 1/4 is the success to the 6th power. What would failure be? 3/4, yeah. 3/4, and then what's left over? 2. 3/4 squared. That's it. That's it. And then you would just get the decimal for that, which was good times. I got this 0.00385. Is that right? Can you check for me? Okay? Sweet. All right. Yay? Okay. Did you paint your nails last night, by the way? It looks good. There you go. All right. The next probability. I like these ones. They look horrible, but it's just common sense. So if x is everything up to including 2, then wouldn't you say this is the same thing as p of x equals 0 plus p of x equals 1 plus p of x equals 2? Right? So if you have like a inequality, you just get up to where you want it to go. Yeah. There we go. P of x equals 0 is going to be 8 choose 0, and then 1/4 to the 0, 3/4 to the 8th. Yeah. Plus 8 choose 1, 1/4 to the 1, 3/4 to the 7th. Plus 8 choose 2, 1/4 squared, 3/4 to the 6th. And I won't make you type all that in, but you can check me. I got 0.679 for that last one. The probability that you would get anything up to or before 2. Yeah? How'd you do the last one? X is greater than 0. What's up? That sounds terrible. I don't want to do it either. How can we get around it? A what? No! And then? Jeez. Done! Done, yeah. I don't want to go up to 8, do you? Hi, Chick-fil-A? We're good? All right, hang on. Chick-fil-A. He's going to do it. He's going to do it. What's that? Oh, sorry. Do I have change for a 20? Oh. Oh, wait.
I wonder why.
Did we calculate it yet? So, this is equal to 1 minus the probability of x equals 0, which we did this one. So 1 minus 8 to 0, 1/4 to the 0, 3/4 to the 8. Did you guys calculate it while we're waiting? Maybe not.
The probability of 0 is 0.1.
Okay, so 1 minus 0.1. 0.9. Yeah. All right. Yeah. Yeah. That's good. Which makes sense because you're just taking away 1 out of the 8 probabilities. So, like, you have a 90% chance of getting more than just 0. That's a good sign. Good sign. What? Lee, did you say word problem? Yeah. Here we go. 72%. 30% of union favors are a member of certain change in their conditions of employment. The random sample of 5 members are taken. So find the probability that 3 members can change the favor and at least 3 members. All right. So would you agree that the random distribution is binomial, first of all? What's n?
7.
And
Oh.
number of members. 5, yeah. And then the probability is 72%, so I'm going to go with 0.72. True? Okay. So the probability that 3 members are in favor of the change, one way to do it, well, the way to do it, is you're looking for x equals 3. So 5 choose 3, 0.72 to the third, so remains. 0.28, yeah. Word. Hey. Talk to me. Got it. Yeah. So 0.293 to 3 significant figures. Yeah. So it's asking for P is, or for X is greater than? Do we do equal to? Yeah. Equal to 3. So I heard it. It's X is equal to 3 plus X equals 4, and I just dropped P, I'm sorry. Plus X equals 5. Yay? Okay. Go ahead and try that calculation. We have this one. Check on mine. Are we getting the same thing? Good. Okay. If you happen to be a fan of proofs. At the very end of this section, there is the proof for the formulas we're going to talk about next. That's expected value, aka the mean, the standard deviation, and the variance. There is a way to get there. But the formula is so simple, you're like, why? right? So if you're asking why, then go back and take a look at that proof. It's pretty amazing. Or if you're like, oh, it's easy. Oh, good. Let's move forward. Okay, here we go. So, yeah, don't be fooled by the simplicity of these formulas. There is a reason why it's so simple. Okay, so here we go. To find the expectation of a binomial principal distribution, yeah, it's just n times p. So, yeah, that was like a lot of work to get to that point. So it's fun if you appreciate proofs. I know it's silly, right? The variance, which remember is sigma squared, is n times p times q. So you multiply the total number of times the probability of success and the probability of failure. And then the standard deviation is just sigma, which is the square root of n times p times q. So again, to appreciate why this is so simple, whole big explanation. Okay? Yeah. Got you. So if you're, let's say you're the quality control. Yeah. So if you're quality control for defective light bulbs, let's say, I don't know, because I'm teacher textbook. If you're quality control for something, right, and you can know what the expected mean is, and then the variance standard deviation. And when you do a sample and you're checking it, if it's like above or below it, you know whether or not your reduction is efficient or not. Yay? Yeah. Yeah. Okay. Well, here's the batteries. 5% of a batch of batteries are defective. Average, right? A random sample of 80 is taken with replacement. So in other words, you put it back. That's not a big deal. Find the mean and standard deviation of the number of defectives in the sample. Okay. Oops. Oh. Yeah. I like it's like my favorite notation. You can do a squiggle, right? And yeah, P. Yeah. So the expected value is 80 times 0.05. Yeah, 4 batteries. So you would expect to find 4 batteries are defective. So if you found 14, you're like, who didn't pay? Somebody, right? Or where did these come from? Yeah, good times. To find the standard deviation, you have to find the variance first. So we know sigma squared is n times p times q. So 80 times 0.05 times 0.95. What is it? Number? Decimal? 3 point something? 3.8. Yeah. Something, something, something. So take the square root of that. I guess I should have just done the square root of n times p times q. But anyway, what did you guys get? Yeah. Would be the standard deviation. That's the expected value. And they all just pass together after. Yay? Okay. Save the thing in the back for when you come back, right? We'll do that together in class next time. Your homework. Oh, proof that girls are people. Awesome. Who did that? Oh, I think Travis did that. Yeah. 1 through 13 odds is your assignment. And again, we'll do the practice together with Alejandro and Aria just to make sure they're good to go.